Space, the final frontier. These are the voyages of the starship Enterprise. Its 5-year mission: to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before.
I am so excited by this next story. Have you seen the pictures from the James Webb telescope? They are awesome. And I wanted to start this segment in honor of our next guest with the great Star Trek opening theme. NATHALIE OUELLETTE, an outreach scientist for the Webb telescope, she was present at the unveiling of these amazing pictures this morning with NASA and the Canadian Space Agency. NATHALIE, thank you so much for making the time this afternoon.
It's my pleasure.
So these pictures are awesome. They're amazing. I just can't find the words. So you, as a scientist who's dedicated her entire life to this, I mean, what's your reaction?
I have to say, I'm also human, and so my reaction was quite similar. I was speechless when I saw them for the first time last week. But then you start looking at the pictures in more detail, and what really blows my mind is how much stuff is in there. Everywhere you look, there's a star, there's a galaxy, there's gas, there's dust, there's just so much stuff. We tend to think of space as an empty thing, but no, it's filled with stuff.
And I love the technical term stuff, right?
That's right, star stuff.
It's star stuff. So tell me more. So what is the most surprising thing so far? I mean, I know you just have this information like a day, but I mean, what is surprising for you? What stands out so far?
What really stands out is the fact that these images were taken over not that much time, only a few hours worth of observations, and they are already rivaling or even beating previous telescopes who need to take observations for days or even weeks to get this kind of detail and resolution.
Okay, so this is like compared, for example, to Hubble. What are we talking? Is like how would you characterize the difference between the old telescope, the Hubble, and this, the Webb?
So we know that the resolution on Webb is a few times better. Its light gathering capacity is 7 times better. And we're also looking at a whole different kind of light here. So Hubble is like a giant human eyeball who can see visible light. With Webb, we're looking at the infrared universe. So we're seeing things that were invisible to us before.
So what has appeared that you didn't see before?
So some of the things that we are seeing just littered all over these images are very, very distant galaxies because their light has traveled very, very long distances over an expanding universe and has actually been shifted from visible light into infrared light. So they were invisible for the Hubble telescope, and they are now just sparkling in the distance with Webb.
So when you say distance, give us an idea. I mean, how far away are these galaxies, are these stars that you're now seeing?
Yeah, so certainly for the galaxies, these galaxies are so far away, we no longer use kilometers. Even the stars, we no longer use kilometers. We use light years.
Light years.
And so the farthest galaxy we detected on these images was 13.1 billion light years away.
Oh, my goodness. I don't even know what that means. So we'll just say it's far away.
It's very far away.
So in terms, obviously, I'm sure others have asked you this question today. What does it mean about, the probabilities of life being somewhere on these planets, in these systems, in these galaxies?
Certainly, planets and exoplanets, it's one of the cornerstones of the Webb mission. We want to find out more about that. We had our first exoplanet atmosphere probe today, very exciting. And so we are going to be able to look at the atmospheres of distant worlds with a degree of precision we've never had before to maybe spot interesting biological signatures, or at least molecules like water vapor or oxygen, which leads us to believe that there might be Earth 2.0s, like Earth twins out there that could harbor life.
And so for a lot of people, spending billions and billions of dollars on this doesn't seem like the right set of priorities. It's not my opinion, of course, but I want you to explain why this type of research and this type of endeavor is so important.
Certainly. So this requires such technological advancements to do this kind of science, and it's driven by our curiosity as humanity to answer these great questions. Where do we come from? How did the universe begin? Is there life out there? But because we have to innovate so much to do this kind of science, we invent technologies and techniques along the way, new inventions that end up having totally unexpected usage in our daily lives. So the camera inside your iPhone was actually originally from space telescope that needed to optimize very, very efficient small light cameras. Lots of techniques that we use in astronomy actually led to advances in medical imagery or telecommunications or material science. So we end up benefiting humanity, and it's being driven by simply our human curiosity to answer all these questions.
So the Webb telescope right now, tell us where is it right now?
So it's orbiting around a spot called Lagrange 2 or L2, and it is at 1.5 million kilometers away from the Earth. So that's 4 times farther away and then the moon.
Okay, 4 times away. Okay, 4 times farther than the moon. Okay.
So if something happens to the telescope, we cannot fix it. So we've made it quite self-sufficient, quite autonomous. And it's over there, and it's going to be observing the sky from that nice little safe point.
So what's next? I mean, it's going to keep sending back images. I mean, what is going to be the use of the telescope moving forward?
Yeah, so the telescope will now be used by the scientific community so that they can have their dreams come true and do their own research projects. So the first year of observations on the telescope have already been scheduled, and lots of that time, hundreds of hours, will go to Canadian astronomers so that they can study their favorite objects, their favorite exoplanet, their favorite galaxies, and they will share all these discoveries with the rest of the world. And that's my job, to make sure that the public is also on the ride with the scientific community.
So what do you hope will be the next discoveries? What's next? I mean, like you said, we always want to know what's next, what's the next frontier. And now we've done this and we're doing this. What do you hope that Webb will lead to?
So after the first exoplanet atmosphere that we looked at today, this was a gas giant planet, sort of like a Jupiter, but much, much hotter. We would love to be able to see something like that, but for a rocky planet that looks like the Earth this time. So some of the next observations we'll be doing on Webb will be that kind of planet, namely TRAPPIST-1, which has 7 rocky exoplanets, many of which might be habitable.
Really? So you're wow. So you're looking at planets that could be like Earth.
Yeah, exactly.
Or once were like Earth, or anyways, and you have enough data, enough information from Webb to pinpoint that, to get that, to determine if a planet is like Earth.
Yeah, and that is the power of Webb, the fact that the data is high quality enough to do that.
And so, in terms of stars, I mean, so you're discovering new stars and new star systems with Webb?
We're studying star systems we already know, but we're discovering new planets around these stars, and we're studying them in greater detail than we've ever done before.
Wow. So, look, I want to thank you so much for coming on this afternoon. I know it's a huge day for you, and please keep up the tremendous work, and I hope we can have you on again to tell us the new discoveries we get from this great telescope. Thank you so much.
Absolutely. Thank you so much for having me.
NATHALIE OUELLETTE is an outreach scientist for the Webb telescope.